Okay, there's a cone. So surrounding this, there's everything is a liquid. Hope you are able to understand because I just share that. The white color, there's a blue color is viscous liquid. This is the cone. Yellow color one is what cone? Okay, now I think you have better diagram in front of you. Very fast. The previous problem, what we had idea, no, the similar conditions will come here. So can we write directly a formula on the total cone? No, not possible, no. So better go for small element. Okay, I finished my diagram. Yeah, no. So this is that omega. Radius r. Theta also given information. There's a viscous liquid. And this is that cone. Typically less than 0.5 degrees settling. Calculate the torque needed to drive that cone. Why torque is needed? Because as you rotate, the viscous layer, the viscous liquid which is present here, it will exert a torque, no? It will exert a force. That force will set up a torque. So we should calculate the torque due to viscous layer. And I should apply equivalent opposite torque so that angular velocity of the cone remains constant. I think this much is what the question that is being asked. What to do now? Where to begin the problem? We should assume it's a plane diagram. Try to assume this is a cone. Rotating cone. The cone has a large apex angle. I think if the 3D diagram, if you can assume, it'll be very easier. So here, let me take a strip. Let it be at a distance x. So you can see, look at that layer here. So here like this, if you assume it, you are going to get a disk, no, here. I'll try. This is the radius of the disk. The structure will be okay. I think I'm okay. This will be dr. This will be dr. You can write it. There's a point too. Okay, here will this is a y. This is r. Able to understand? So shall I call this a disk or it's a ring? Anybody? Will you encounter here a ring, or shall I assume a disk on a cone? Shall I assume a ring on a cone? The liquid will be in contact with the cone here, no? So therefore, actually what it is, this is a ring on the cone. Where the liquid will be contact only in this shaded part here. Here the liquid will be in contact in this one. Like this, what I'm assumed a ring of radius 6. at a distance y, and this will be slant length r. I think more than this, I don't have explanation. After this, you should have that basic observation here. So here where the liquid is in contact here. Liquid is in contact in this region. I think, okay, if you can make this much here. What is the mathematics? Will go for it. Cos theta. Yes, given that apex angle, large apex angle, and the angle, the cone has a large apex angle and the angle theta shown. I think theta is not apex angle. Theta will be large, since apex angle is large, theta will be very small. So cos theta equal to x by r. So dr is also will be there. So let me differentiate this. Dr is equal to, theta is a fixed, no? So dr is equal to dx by cos theta. I want this area of this element. Anybody? Because in the viscous force, I need the area of contact, no? What is the circumference length? What is the perimeter of this? 2 pi x. And there's a width, no? dr. If it were vertical, I would have wrote that one. So since it's a inclined one, so therefore the dA will be 2 pi x into dr. Okay, the dr is what I'm going to replace from this equation. In exams, I think you should really you should understand the diagram. That's what I feel. Okay, dA, we got it. What is the velocity at that particular point? Should be equal to x omega. Okay, let's write the force acting on the ring. So I'll write it. Elemental ring. Okay, force, viscous drag on elemental ring. dF is equal to, what shall I write? Quotient of viscosity eta. What is area of that elemental ring? dA. What is dA? Area of elemental ring. What is the speed of that? V. Omega. Let me show that tangential speed. V like this. I think better. Yeah. So what is V is equal to? V equal to x omega. I'll write it. What about the thickness? Because velocity gradient will write it. So shall I write divided by R or divided by Y? Because in the viscosity formula, eta A dV by dx will get, no? So that dr something will write. So shall we write this is Y? Velocity will be V. And what is this from the reference layer? It will be Y, no? This is the most difficult part of the question. Once you get this rest of mathematics here, now you can say I'll substitute. This will be eta dA will be 2 pi x dx cos theta. V is x omega, and this is Y. We don't know why. Y should be eliminated. Y shall I bring in terms of x? Tan theta. Y by x. So Y equal to x tan theta. Eta 2 pi x dx cos theta x omega. Y I'll write it as x tan theta. So 2 pi eta. What all will get eliminated? Omega. Cos theta into tan theta will be sin theta x dx. This is a force viscous drag on elemental ring. So will there be any torque? Yes, there'll be torque. So let's go for torque. Torque equal to dF into, what shall I write torque? R into df, R into df, or X into df. Let me show that. I think I'll bring it here. This will be V. This will be df, no? And this is omega. Okay, fine. So what is df? Df will become X into df will be the torque. I think I'm in better position, or you convert into plane diagram. Velocity, this will be df. So what is the torque? Torque should be df into x, not df into r. So 2 pi eta omega sine theta. What shall be the limit? Torque about axis O, 0 to capital R. 2 pi eta omega sine theta r square by 2. Get cancelled. So pi eta omega r square by theta very small. We can put it. Theta, it should be in radian, not in degrees. Okay, there's a torque. What happened? That should be applied on the cone to rotate it with constant angular velocity in this one. So different types of structures will come, like disc, cylinder, cone will be rotated. So that torque we have to apply. What we calculate is torque due to viscous layer equal and opposite to that, the external torque should be applied. Okay, then this is like a torque due to R cube by 3 will come. Okay, fine. Yeah, R cube by 3. So 2 pi. Okay, I made correction. Can be asked. I think you check the EDO notes. So there are some set of questions of like this also there. So possibility of asking advanced. No? Let's come for a few more questions on viscosity. Please read question. Where the person's hand is here.